Hi everyone, I'm Izzy, and I'm excited to tell you all about what I've been up to this summer. I've been working on maintaining NetCDF, so updating Java tutorial code and performance testing in Python. And before I get started, I want to thank my mentors, Haley Johnson and Sean Arms, for all of their help on this project. So first, I want to talk about my motivation coming into the summer. I really wanted to learn more about NetCDF. I had worked with some NetCDF files in MATLAB, just using high-level functions like NCOpen, NCRead, but I didn't really understand how that connected to the C library or the other libraries that Unidata supports. And I also wanted to promote education. So as someone who was learning about NetCDF on my own, online, I really wanted to improve and work on some of the online materials. And finally, I wanted to learn more about storage and efficiency because that is something that I do not know a lot about. And I'm happy to say I learned about all of these different things, and I really enjoyed the hands-on learning style that I got to experience. So throughout the internship, I noticed some themes with what it takes to maintain a code base. The first is documentation and tutorials. I learned that as a library evolves, how quickly docs and especially code samples can get out of date, and also adjusting to new technology. So how does a library continue with different versions, and how does it adjust to what users need and other advances happening in the field? So for the first part of my summer, I worked on the NetCDF Java user guide and tutorials, and I worked in version 6 and then backported to version 5. And these are all of the pages that I edited. The coordinate system section was the most challenging for me because that one had the most changes with the structure of the library. So a lot of the interfaces that were implemented in the code samples no longer existed, and they were replaced by abstract classes. And so that took a little bit more digging around. And then scientific feature types, that was looking at grid and coverage data sets. And that was more straightforward, but it did have some structural changes that I adjusted to. And finally, the runtime configuration section, that was more straightforward. I focused on updating the writing and the images. And in that section, in the system properties page, I noticed a note that said, like, this is deprecated or this is going away. And because it was a couple versions old, I knew it would be different. So I got to get the approval of my mentors and actually go in and make a small change. And it was very minor, but that felt good to like leave the docs section and go into the core Java. So that was fun. So what did I do with the docs writing? These are some of the things I did. I converted raw HTML to Markdown just so that everything was a little bit more uniform across all the tutorials. I made some format updates. There was one page that talked about installing libnetcdf, and it had for each operating system the specifics and then build from source with a link. But the build from source with the link section was the same for all of it, so it was just repeated. So I consolidated that and just made it a little bit more concise to read. And I also linked to other relevant sites. Some of the links on there 404'd, and some of them were just not pointing to the most relevant thing. So I did some research and added links that I thought would be the most helpful. And finally, I updated images. So that was mostly updating UMLs, but I also got to update some screenshots of Tools UI, which was fun for me to make plots and screenshot it and add that up. So this is an example of a UML diagram that I updated. This is the before, and here's after. So you'll notice that there was some changes with the packages. And in this example specifically, there were changes with interfaces turning into abstract classes. So I wanted to make that clear and just make it look slightly more modern and up to date with the rest of the website. And then next, after doing the writing changes, I spent most of my time working on the tutorial code. And prior to my work, all the Java code snippets were in the Markdown file, which was nice because it was all in one place, but it was really hard to notice if the code went out of date. You just have to catch it by eye. So I worked on creating Java classes, so one class for each page, and then each code snippet went into its own method. And then when I had it in IntelliJ, it was really clear in bright red if something was deprecated or if something wasn't compiling quite right. So that is where I was able to update some of the code. And some of those changes were small changes like a class name or a method name changed. And some of it was a little bit harder to figure out. And I had to think about, okay, what is this trying to achieve? And then kind of search through the library and look for solutions. And after I finished all of that writing of code, I created some simple tests just to make sure that it was working. And this changes that were made, I'm hoping that it's not only beneficial for getting up to date with version 6, but that as the library continues to have changes made to it, that the docs won't be left behind, because now we'll have a test that fails and says, okay, let's go update the doc code snippet. So this will hopefully keep the docs moving at the same pace as the rest of the library. And here's an example of just a screenshot of one of my pull requests. So this blue text over here is the Java code in the Markdown file. And then on the right, this is the Markdown file using the NetCDF Jekyll plugin. This was used in some other docs, and I adopted this structure. And then this looks for a method that I created, find lat lon val. So here's that method in a separate Java class, and then it will just insert that code snippet into the rendered HTML. And another thing here, this is an example of some of the structure changes. So here we're opening a grid data set, and this was UCAR NC2 DT grid data set open. But the DT package is no more. So I realized, okay, there's a grid package, but there's no open function. But it turns out there was a open grid dataset function. So that's an example of some of the name changes and the searching around that I was doing in there. And after I finished that docs work, I then moved on to looking at some performance testing. And I mentioned at the beginning of the summer that I was interested in storage and efficiency, and I wanted to learn about it. So my mentors suggested that I look into comparing some data formats. And I knew a little bit about HDF5 just from working with NetCDF Java. I was like, okay, we use this for chunking and compression. But I didn't know very much at all about ZAR. And I heard about ZAR through articles that we had circulating on Slack. And I got to attend the ZAR talk and the EarthCube conference. And that was a great thing about this internship, was learning about what's happening in the field outside of Unidata. So I wanted to know what all the talk was about and kind of start to learn more about it. And so I dipped my toe in the water and did some performance testing to learn about these. So these are the data formats that I compared. The data I got from the Unidata website, it's from the Community Climate System model. And the original data was a NetCDF3 file, so no compression or chunking. And then I converted that into NetCDF4 and NetCDF4 Classic using the NC copy utility. And both of those use HDF5. And next, I needed to convert to a ZAR directory store. So I researched and I found a Python repository that helped me do that. And then finally, I was also curious about Xarray. I had never used it before, so I wanted to kind of compare reading with Xarray as well. So here is my benchmark test. I did all of this work in Python, so that was exciting, switching from Java to Python during the last couple weeks. And I made it in Jupyter Notebook because I wanted it to be easily accessible, and I want people to add to it. I'm going to come back and add to it pretty soon. And I included the QR code, so if you're interested, you can go take a look at the code and the data that I used. But basically what I'm doing here is using the Python timeit function, and then specifying my imports before we start timing. And then this is the chunk of code that we time. And here I'm just looking at the first value in each variable. And so here I'm calling timeit, set up the imports first, and then time the code. And here I ran it for 1,000 times and then took the average. So this was the initial results that I got, and this is with no additional chunking. This is with one chunk per variable, so pretty large chunk sizes. And here we see ZAR being the fastest read time, followed by netcdf3, which makes sense because it's not compressed. And then Xarray reading ZAR was slower, which surprised me. And also all netcdf4 and netcdf4 Classic were the slowest for this example, and all of those use HDF5. So this was really interesting, and I talked to my mentors about what was going on here, and we decided that the next step would be to look at how this changes with chunk size. So I decreased chunk size by factors of 4, and this is what I got. So here is our initial large chunk size. It's 128 by 256 for lat long, and that's what we were looking at in the previous bar graph. But as chunk size decreases, the read time of a ZAR directory store becomes slower than netcdf4 being read by netcdf4 Python. So this was really interesting. It showed how important chunk size is and where the crossover was with this data set for which software read was the fastest. And next, I added in ZAR with Xarray, and we can see that it's slower. And then I also added in Xarray reading the same netcdf4 file. And this was confusing to me. I didn't understand why Xarray was slower because it's using the same netcdf4 Python and ZAR packages. So I reached out on Slack to the Python channel, and I learned that it's just not loading all the data until specified. So when I reran this loading the data, it took what felt like 10 minutes for the small chunk size, and the graph looks really different. Xarray is much slower, so that kind of explains what's happening here. So for a deeper explanation, as I understand it, as to why the read times are different, all has to do with the way that the data is stored. So a ZAR directory store, the more chunks you have, the more individual files in the store. So you have your ZAR directory store, main file, whatever it's called, and then within there, there's a folder for each variable. And then in those folders, there's files depending on chunk size. So when chunk size was small, 4 by 4, some of the variables had over 2,000 files. And when ZAR did the read, it opened all of those files. So it spent more time opening than it did reading the single values that I was asking it to. Alternatively, netcdf4 stores all of the data in one .nc file. So you only need to open it once, no matter what the chunk size is, but you may need to spend more time looking to find the data. But when chunk size is small, that one open is really beneficial. And finally, Xarray could be useful if you're not looking to load the data and you just want a quick read. So for some next steps, this is just the testing that I was able to get done in the last few weeks of my internship, but I'm really interested in adding more comparisons. And next, I will be working back with netcdf Java. And Haley just completed last week a read capability. So now that that's done, I'll be able to compare the ZAR implementation with HDF5, and that'll be really exciting. And then I plan to kind of reorganize, get that testing done, and then I'll present all of this at AGU. And here I have this poster that I will be presenting tomorrow at the NCAR UCAR wide poster session, but I think at this point you all have heard more than enough about what I did, so I'm not going to go over this, but I'll be making a new poster for AGU in the fall. And that's all that I have prepared. Thank you all for listening and for making this remote internship really great. I had a lot of fun.
Very nicely done. So, are there any questions for Izzy?
I do have one. So with regard to the findings, which are very interesting, chunk size versus the algorithm that you're using for storage and archiving, ZAR seems to be promising for the smaller chunk sizes, right? So my question actually with regard to this is whether we can also attach the likeliness of using one over the other based on the real sample, real data. So meaning that we would use this versus that one based on the chunk sizes that we can find out there in real life. So just question whether I have considered that and whether it's meaningful or not to do that.
Yeah, I think that would be a really great information to have. Like, if this is the chunk size you're trying to use, this is the data format to use. What I did is not robust enough to make any kind of generalization, but I do think this could like start a larger like progress in that way. But also this is just for, it's like a POSIX file system. It's not for being stored on an object store. So that would also need to be considered, but that's a good idea.
Thank you. It was a good presentation. Excellent.
Thank you.
So I have a question, Izzy. Thanks for your presentation. That was great. If you can step backwards into talking about the tutorial code that you inserted into the NetCDF Java docs. And I'm interested in how you got that code into the testing framework and whether those tests are now automated so that when the documentation builds or when the package builds, when does that automated testing sort of kick in? I'd like to understand that a little better.
Yeah, that happens when the docs are built.
Okay.
Yeah, so anytime the docs are built, the tests will run.
The tests on the doc samples will run, or the tutorial code samples will run. That's great. Is that something that we might be able to generalize into other areas of Unidata documentation?
Yeah, I think so. I think that's really important because it's easy to forget about updating the doc code samples. So I think that would be a great thing to have in other software. Yeah.
Cool. Thank you.
I had one more question sort of along those lines. Do you have a URL of an example of where the actual documentation page that we can see of how it looks?
Yes.
Cool.
I can look that up and put it in the chat, but it'll take me a second to find.
Okay, no worries. And
yeah,
to follow up on Doug's question, does the test run like with a GitHub action? Is that how it's triggered?
I'm not actually sure on that. I think it is, but I think it runs with both the GitHub action and if you're just building it locally.
Oh, okay, cool.
Yeah.
I see Sean's comment.
Yeah, so the answer is yes.
Any other questions? All right, well, if not, another round of applause for Izzy and her hard work. Very much.